this video, we're going to talk about equivalent expressions with polynomial denominators. So what does that mean? So I'm going to take a rational expression, which is just a fraction that has the variables in it, usually in the denominator. So in this case, we want a polynomial in the denominator. So it's going to be something like x plus 2 or 4x minus 7, or maybe even something squared like x squared plus 3x plus 4, okay? So we're going to take a fraction that has variables in the denominator, and we're going to write an equivalent fraction, a fraction that's equal to that. So I just wanted to look at this really fast and just talk about equivalent fractions. To make a fraction that's equivalent, we're just going to multiply, usually, sometimes divide, but both ways, multiply or divide the fraction by the same number on the top and the bottom to make something that's equal. So if I start off with an already reduced fraction like 3/4, if I multiply both the top and the bottom by 3, I get 9 over 12. So this fraction, 9 over 12, is equivalent to this fraction, 3 over 4, okay? It can go backwards. You can also divide. So if I wanted something that we knew was the same as 1/2, let's just call it 4/8. If I divide the top by 4 and divide the bottom by 4, I get 1/2. So I'm taking my fraction and I'm either multiplying it by a number, the same number on the top and the bottom, or dividing it by the same number on the top and the bottom to get something that's equivalent. And we can also do this when we have variables in here. So here, if I wanted to make an equivalent fraction, if I multiplied both the top and the bottom by 4, I would get 4x over 16. So that x over 4 and 4x over 16 are equivalent fractions. So now, in this lesson, we're going to do the same thing, except we're going to have a polynomial in the denominator. So our denominator is going to look something like x minus 3. Or x squared plus 2x minus 1, okay, something like that, just with a polynomial in the denominator. So I have two examples for you, and then we're going to talk about why we even do this. So in my first example, I have 6x over x minus 7, and they want to know, I want it to be equivalent to this on the right-hand side, where my denominator now changes to x minus 7 times x minus 8. So what did I notice? I noticed that my denominator got multiplied by x minus 8. So remember, whatever you do to the bottom, you have to do to the top. So this becomes, I'm going to multiply it, and I get 6x times x minus 8. But we also have to simplify on the top. So we can keep the bottom the same, x minus 7 times x minus 8. But you always want to multiply out the top. So I'm going to distribute this 6x. So 6x times x is 6x squared. And 6x times negative 8 is negative 48x. And this would be your final answer. Okay. We'll talk about why we multiply out the tops and not the bottoms in just a minute. Our next example says 2v over 8v minus 5. And they want me to write an equivalent fraction with now my denominator turned into 48v minus 30. Okay, so what happened? So this 8 turned into a 48, and this 5 turned into a 30. So it looks like I multiplied by a number. So I'm going to ask myself, 8 times how much is 48? 6. 5 times how much is 30? 6. Good, should be the same. So what I did is I took the bottom and I multiplied everything on the bottom by 6. So that means I have to multiply everything on the top by 6. So this becomes 2v times 6. And 2v times 6, we're going to multiply that out, is going to give me 12v over 48v minus 30. This would be your final answer. Okay, so why do I have to know how to do this? We do this process to help us solve polynomials or equations with polynomials in the denominator. They're called rational equations. And the first step when you solve a rational equation is to make a common denominator. So I'm not going to solve the whole thing for you, but I just want to show you that we want to make a common denominator out of all these terms. -2, 5 over u plus 7, and 7 over u minus 3 times u plus 7. So if all the denominators have to be the same, all my denominators need to be here, u minus 3 times u plus 7. So I would say, okay, this here denominator is missing a u minus 3. So I would multiply on the top times u minus 3. This denominator here on the 2, it's really a 1. So this is missing everything. So this is missing a u minus 3 and a u plus 7. So I have to multiply this times, whoops, sorry. Times u minus 3 and u plus 7. So when I write this all out, plus we did our purple, equals what we have as blue. Okay, so my pink guy, I have my 2 and I multiplied by u minus 3 times u plus 7, and my denominator is u minus 3 times u plus 7. Okay, so I multiplied by that on the top and the bottom. My second one, I had 5 already in u plus 7, and I multiplied by u minus 3 on the top and u minus 3 on the bottom. So my denominators are the same. Now, does it matter that u plus 7 is written first and u minus 3 is written second and it's switched over here? No, because the order that you multiply does not matter. Remember, 3 times 2 is the same as 2 times 3. So it doesn't matter if I switch my order when I'm multiplying. And then my last one on the right, I didn't have to multiply by anything. So this one is just going to stay the same, 7 over u minus 3 times u plus 7. Now when we're going to go ahead and solve this, this is why you would multiply out everything on the top, but we'll get into that in a later video. I just wanted to kind of explain what the purpose is of finding rational expressions that are equivalent. It's so that we can work towards the next step, which is solving equations with them in there. Let me know if you have any questions. Good luck.